Hello and welcome. In this video, we'll be discussing how to solve a rational equation like the one you see on your screen. So my preferred first step in solving a rational equation is to clear out the fractions without changing the balance of the equation. So if we want to clear out the fractions, I want to multiply both sides of my equation by the least common denominator. So our first step is to find that least common denominator. So if I want to find that least common denominator, my first step then is to try to factor my denominators as much as possible. So if we look at this first guy, notice that I can factor a 4 out of both of those terms. So I'm going to leave the numerator the same, that'll just stay as 8. The denominator, I'm going to factor a 4 out of both of those terms. If I factor a 4 out of the first term, that leaves me with x. If I factor a 4 out of the second term, that leaves me with 6. And then minus 1, don't need to worry about that. Its denominator is just 1. And then the last guy, well, there's not really much I can do in terms of factoring. So I'm just going to leave it as it is, and then just put parentheses around it. So the least common denominator is going to be a multiple of my denominators. So if it's going to be a multiple of both denominators, it has to have all the factors that both of my denominators have in them. So in this case, my least common denominator has to have a 4 and an x minus 6 to contain all the factors in each denominator. So now that I've found that least common denominator, my second step then is to distribute or multiply that least common denominator to both sides of my equation. So I've just rewritten our equation and I've written our steps. So we're going to distribute that least common denominator to both sides of the equation. So I'm going to start by just putting each of my original terms in parentheses. And then I'm going to multiply each of those terms by 4 times x minus 6 over 1. So since the 1 isn't a fraction, I'm just going to leave the over 1 out. And then on the other side, I've got times 4 times x minus 6 over 1. Okay, now I just want to clean up what I have. So if we look at that first term, notice that I can divide the top and bottom by 4x minus 6 because I have a 4x minus 6 on the top and on the bottom. So if I divide out by those factors, well, the 4's become a 1, the x minus 6's become 1's, and then if I multiply what's left, well, 1 times 8 is just 8, and then the bottom just stays as, well, a 1, because 1 times 1 times 1 is 1, and since it's 1, I don't need to write it. When I look at the second term, I've got 4 times x minus 6 times 1. So I'm going to start just by multiplying the 4 and the 1 together, and that leaves me with 4. And then I'm just going to leave the x minus 6 behind, so just in factored form. On the other side, when we look at that guy, well, notice that I can divide top and bottom by x minus 6. So if I do that, those x minus 6's become 1's, and then if I multiply what's left, on top I've got 4 times 1 times 2, which is 8. On the bottom I have 1 times 1, which is 1. So the next step then is just to solve the equation that's left. Okay, so I've just rewritten our equation. So the first step in solving that equation is I want to distribute this negative 4 through that group, that x minus 6 group. If we do that, I leave the 8 the same, and then negative 4 times x is minus 4x. Negative 4 times negative 6 is plus 24. On the other side, I have 8. And now I can combine like terms. So on the left-hand side, I've got an 8 and a 24. So if I combine those, 8 plus 24 is 32. Minus 4x equals 8. And again, what I'm working towards is getting x alone. So I'm going to subtract 32 from both sides. If I do that, I'm left with, well, the 32's become 0, so I'm left with negative 4x on the left-hand side. On the right-hand side, 8 minus 32 is negative 24. And then the last step, let's divide both sides by -4. If I do that, I'll have x equals 6, looks like my candidate solution. So you'll notice I haven't boxed that solution in, and I called it a candidate solution. Whenever you're solving a rational equation, you always stand a chance of getting a solution that actually doesn't work in the original equation. It's what we call an extraneous solution. So the fourth and final step is I need to take my candidate solution, x equals 6, plug it back into the original equation, and see if it actually works. Okay, so I've taken our solution, x equals 6, and then I've just copied the original equation down. So what I'm going to do is I'm going to take this candidate solution, plug it in for x, and what I'm really concerned about is I don't want to have a 0 in the denominator. Because if I end up with 0 in the denominator, I have a term that's undefined. So I would have to throw my solution out. So here we go. If I plug 6 into the denominator of that first term, I've got that. On the other side, if I plug my 6 in, I'll have... So a couple of problems actually I already see. So when we look at the first fraction, you'll notice that if I take 4 times 6, I get 24. 24 minus 24 becomes 0. So I end up getting 0 in the denominator. And that's really, what that really means is my solution doesn't actually work. It produces an undefined term. Same thing, actually, if you look at the other side, I've kind of got the double whammy here because 6 minus 6 again produces a 0 in the denominator. It really doesn't matter because once I get 0 once in the denominator, I know my solution is not valid. So what that means about my solution is I have to cross it out. Doesn't work. It's what we call extraneous. And since that was my only candidate solution, I have no solutions left. So my final answer for this problem would be no solution. Now, if I would have plugged my number in and I wouldn't have gotten a 0 on the bottom, that would have been a valid solution. I could box it in, and that would be my answer. Okay, so here's another one for you to try. Pause the video after you've given it a shot on your own, restart the video, and see if you have the process down. Okay, so our first step is to get that least common denominator. So I'm going to start by factoring our denominators. The first guy we really can't factor, so I'll just leave it as it is. The second guy, however, I can pull a 2 out of both of these terms. So if I factor the 2 out, we're left with a 2, and then on the inside I've got w plus 2, and then minus 2 at the end. So that means my least common denominator, well, it's got to have both a 2 and a w plus 2 in it. Okay, so I've just rewritten our equation, but then I've left a lot of space in between my terms because my next step is to multiply both sides or distribute this guy to both sides of my equation. So the way I start that again is I put all the terms in both sides of my equation just in parentheses, and then I'm going to multiply each one by 2 times w plus 2 over 1. Okay, and the last one, I don't need to put the over 1 because I'm not multiplying that guy by a fraction. So I'm just multiplying it by 2. So then what I want to do is try to divide out common factors from my numerators and denominators. So when we look at the first fraction, you'll notice I have this w plus 2 factor on the top, w plus 2 factor on the bottom. So if I divide out by the w plus 2 top and bottom, I'm left with 1s in both places. So then if I multiply what's left, 2 times 1 times 7 is 14 on top. And the bottom is just 1, so I don't even need to write it. When I look on the other side, I can divide top and bottom this time by 2 times w plus 2. So when I do that, I get 1's, and if I multiply what's left, I get 1 times 3 on top, which is 3. On the bottom, I just have 1 times 1 times 1, which is 1, so I don't even need to write it. When I look at the second term on the right-hand side, you'll notice that I have 2 times w plus 2 times 2. So we can multiply those numbers first, commutative and associative properties of multiplication. So if I do that, 2 times 2 is 4, and then remember we have this minus sign in front. So I'm going to have minus 4, and then I still need to multiply that by the w plus 2. Okay, then I just want to solve the equation that's left. So I've got 14 equals 3. Let's distribute the negative 4 through. So we do that. Negative 4 times w is minus 4w. Negative 4 times 2 is minus 8. We can combine some like terms. So I've got 14 equals 3 minus 8 is negative 5. And then minus 4w. From there, we can add 5 to both sides. If we do that, we've got 19 equals negative 4w. And then the last step, divide both sides by negative 4. And that fraction doesn't really simplify, so my candidate answer is just w equals negative 19 fourths. Okay, the last step then is to check that solution in the original equation just to see if it actually does in fact work. Okay, so I've rewritten our original equation just below our candidate solution. So now I'm going to plug in negative 19 fourths for w. So if we do that on the left hand side, we get 7 over negative 19 fourths plus 2 equals, on the right hand side, I've got 3 over 2 times negative 19 fourths plus 4, and then minus 2. Okay. So we're going to cheat a little bit here. You certainly could carry through the calculations all the way to see if the left and right sides are equal to each other. But really what I'm most concerned about is that my denominators are not 0 in any case. So on the left-hand side or on the right-hand side. So when I look at the left-hand side, I've got this fraction with a denominator of negative 19 fourths plus 2. Well, right away, I know that since this fraction doesn't simplify any, there's no way that when I add it to 2, I'm going to get 0, because the only number plus 2 that equals 0 is negative 2. And this guy certainly doesn't simplify to negative 2. So this guy's perfectly fine. What about on the other side? Well, on the other side, we could use similar reasoning. So negative 19 over 4 doesn't simplify again. The only number that adds with 4 to give me 0 would be negative 4. So this guy would have to simplify to negative 2, so that when I multiply it by 2, I would get negative 4, which then when combined with 4 would give me 0. So there's no way that this guy equals 0 overall either. So in fact, I'm actually done. I know at least my solution is not extraneous because I didn't get that 0 on the bottom. So one little word of warning on this though. Just because I found that my solution is not extraneous again, I don't know that it in fact works. It could be that I made a mistake along the way. So if I wanted to be absolutely certain that my solution works, I would want to carry the calculations through on both sides to make sure that both sides do in fact equal each other. So knowing the solution isn't extraneous isn't the same as knowing that your solution is correct.